Okay, so we started with writing down the time. We started by writing down the distance, so those are just our given values. We're solving for VT and omega. So let's start by finding the tangential velocity. So the tangential velocity equation is 2 pi r over capital T. Now be careful. This capital T and this capital T are different. This is just to tell you its tangential velocity. This capital T is called the period. It's the time to go around once. So I'm going to plug my numbers in. So 2 pi r. So r is the radius. So here is the sun. Here is the Earth. Wow, the Earth is bigger than the sun, apparently. The distance between them is the radius of Earth's motion. Okay, so the radius of Earth's motion is the distance between them. So r is just 1.496 times 10 to the 11th. Period is the time it takes to go around once. So it takes 1 year to go around once. That is 3.16 times 10 to the 7th. And notice that this one is not squared. The other one we did was, this one is not. So I'm going to multiply the whole top together first. And then I'm going to divide by the bottom. So 2 times pi, and you can put 3.14, that's totally fine, times 1.496 to the 11th. When I multiply those three things together, I get 9.4 times 10 to the 11th. Divided by 3.16 times 10 to the 7th. Let's go ahead and divide that out now. So answer divided by 3.16 to the 7th. So the answer is 29,745.7. So, just so you know, while you feel like you're at rest, you're actually traveling through space at almost 30,000 meters per second. Which, if you're wondering what that is in miles an hour, that's over 60,000 miles an hour. So there you go. Just pray the Earth doesn't stop moving or you'll go forward at that fast, which would be bad. Yes?
So I did 3.14 and I got like similar numbers for the seconds.
And that's okay, as long as they're close. So as long as you're getting around 29,745. What'd you get?
I got 297,000.
297,000. Okay, I'll come look, because that means you got an extra 10 in there somewhere. So my guess is it's one of these numbers. I'll come look at it, though. All right, that takes care of the tangential velocity. Now we got to do the rotational velocity. The rotational velocity equation is this one. Number of rotations divided by time times 2 pi. Notice it's not capital T, so it's not the time for once, it's the total time. So omega equals number of rotations over total time times 2 pi. So the number of rotations is once. The Earth goes around one time in a year. The time it takes to go around is still 3.16 times 10 to the 7th. That's still how long it takes to make 1 year. Times 2 pi. So 1 divided by 3.16 to the 7th. And then that number times 2 pi. So times 2 times pi. And we end up with 1.99 times 10 to the negative 7th. And this unit is radians per second. Now, you might be saying to yourself, Mr. B, how can one number be so large and the other number be so small? Here's why. This is a straight line speed. The Earth has to go really fast to go around the sun, or it would crash into it. However, this is an angular measurement. How much of an angle does the Earth travel per second? Well, the Earth is not going to travel very much of a circle in 1 second. Even though the Earth is making high speeds and going fast, the Earth's circle is so large that it only travels a really tiny portion every second. So this number is really small because the Earth does not rotate much of the circle in 1 second. But this number is really big because the Earth has to go really fast in order to get all the way around the sun in that amount of time and to not crash into it. Okay? All right, I want you to try number 1 on the back. I'm going to give you the rest of the period of work here to try to finish up the practice. If you get done early, work on the review guide. Okay? Again, we don't have a ton of in-class time to work on the review. Here's the next problem. Samuel and Hannah are both riding a carousel. Hannah is on a pony, which is 4 meters from the center. Samuel is on a water buffalo, which is 5 meters from the center. Carousel goes around 15 times over a course of 60 seconds. Find the rotational and the tangential speed of Hannah. Find the rotational and tangential speed of Samuel. And then when you're going to get the same answer for rotational speed. And you're going to get different answers for tangential speed. So the question I have is, why is that? So think about why one might be the same and the other might be different. Okay? All right. Use your time wisely. Get practice 1 knocked out. See if you can finish it before you leave. You got a little bit more than 10 minutes left. Closer to 15, actually. So you got plenty of time. Make sure, though, that you're getting these answers first. I'm going to leave it up on the board here. Make sure you're getting these answers first. Once you've got them, then go to the back page and start working on the practice. I'm going to do a homework check on this next time. It'll be the last homework assignment besides the final exam review guide and the final exam. So do a good job on it. Make sure that you get it knocked out, and then we will go for there. Okay? So go ahead and work. I will come around and